Okay, so today we're looking at the inclined plane. So the inclined plane, normal force Fn acts perpendicular to the surface of contact. So when we start these questions, the instinct is to use our conventional horizontal x and y axes, right? That's what we're used to. But when we actually analyze this scenario, what we recognize is that our acceleration is down the ramp. Well, it could be down or up the ramp depending on what external forces are being applied. But if you put a block on a ramp, the tendency is for it to just slide down the ramp. So the acceleration is going down. What we end up noticing though is because it's down at an angle, our overall acceleration has a x component and a y component. And don't write this stuff down. I'm going to redraw it how we solve these afterwards. Also, what's happening is that we have a normal force which is perpendicular to our surface. So here's our surface. If we were to, and we have that perpendicular normal force. Again, this also has an x, Fnx, and Fny. And there's also force of gravity going to go downwards. Force of gravity. If there was friction, friction would be in this direction, and friction would have a force of friction x and force of friction, and overall it's just getting really, really complicated. So what we do, instead of using our traditional x and y axes, because we know this thing is going to be accelerating either up or down the ramp, depending on if there's external force or like what its initial velocity might be, what we do instead is we're going to set our x, y axes, or our x axis is going to be parallel to our surface, and our y-axis is going to be perpendicular to our surface. So we call this x prime and y prime. It doesn't really matter what you call it. It's going to call it x prime and y prime. So instead of our traditional x and y axes, we're going to do an angle. We're going to just rotate our frame of reference. So if we draw our forces on this again, so what's happening with this block is we have force of gravity is going downwards. Force of gravity. We have normal force that's up and to the left. And then what's going to happen is we know this thing's going to accelerate down and to the left. I'm not actually going to draw that one. So like our net force, if we actually combine all of our individual forces, if this is the frictionless scenario, if we have one more, it would be force of friction would be away from it. Force of friction, always opposing the direction of motion. What we can notice here is a lot simpler. So instead of having like the net force having x and y component, the normal force having x and y component, the force of friction having x and y component, we see normal force is in that x prime direction. Force of friction is in our x prime, so our normal force in our y prime. However, force of gravity does have an x and y component, so it's going to be Fgx and Fgy. So when we actually write out our equations, you can say, okay, we have forces in the x and y direction. So sum of the forces in our y prime direction, let's say a y prime, is equal to mass times acceleration in the y direction. This is equal to 0 because we know this thing's not going up and off the ramp or through the ramp. So it's equal to 0, and we can see that there's Fn is going in that positive y prime direction, and the only other force in the y prime axis is that force of gravity in the y direction. So what we get from there is the normal force has to equal to the y component of Fg. In the x direction, sum of the forces in the x direction, we have max, right, so that's our net force, and what's making it fall down, there's the Fgx, so the x component of force of gravity minus that force of friction. So one more thing before I finish this video is we need to find out how do we solve for Fgy and Fgx. So when I look at this triangle, let's just draw it again over here. Here's the triangle. Here's my block. and I have that vector down there. If this is some angle, say 30 degrees, this FGX is perpendicular to the horizontal axis. So if this is 30, this must be 60. If I were to draw another triangle like so, if that's 60, this must be 30 as well. Okay, let me just draw it one more time so we can see it. When we draw this FGX vector, the one line's down, is just straight down. The y component is perpendicular to the surface, and the x component is parallel to that surface. So if this is 30, this is 90, this must be 60 degrees. Again, this FGY is perpendicular, so if this must be 30 degrees. So the angle right here would be theta. So if you want to solve for FGY, we see that FGY is going to equal to FG, and it is the cosine component of FG. And FGX is the sine component of FG.